Okay, so hello, my name is Jarosław Kowalewski, and I work in visuality like for about 3 years as Ruby developer, and I would like to introduce you the SQL materialized views, as the topic is in Ruby on Rails and PostgreSQL. So basically the plan of this presentation is like to go through views, go through materialized views, like introduce how they work, what are the differences, and then how we can incorporate the SQL materialized views into our application. And I would like to give a small example about how I could use materialized views in a live project, let's say. So let's go further. So basically, what are SQL views? So SQL views are virtual tables in database whose content is defined by query. So there's a short example how view is created. So basically, you can see that it's just a query. And view is kind of like definition of this query, let's say. So basically, you can say it's kind of like abstraction layer, which keeps our query in a view and the view contains this definition. So what are pros of SQL views? So let's say first is pretty important, and is security, because we can give privileges for specific users that are available to use specific views. So for example, admin, customers, users, and so on and so forth. And limited exposure of tables, or exactly exposure of data, so we don't have to exposure whole tables, so we can just exposure this limited data that is limited by this view. Also the simplicity, so let's say we can hide the complex query, and what is connected with that is reusability, so also we can reuse this, let's say, hide that complex query to our further operations, so we can again query that view and going further with that. And the question is, does view increase the performance? And I heard some stories that say that it's maybe at the planning time it might be slightly different, but in general SQL views serve us only as an abstraction layer, nothing more, let's say. So going further to more like different types of views, so the most popular, there are 2 types of views. Indexed views that are used in SQL Server, and materialized views that we can meet in Oracle Server or PostgreSQL Server. Also, we can tell that in MySQL you won't meet any of them because they just do not support anything here. Basically, you can do a trigger with tables or something like messy error support, like around working solutions, but I do not recommend that. So basically, the first example was indexed views. So those views are served in SQL Server, and basically you can store the view with clustered index in database. So it is done with in the way that you define your view with schema binding, and you also have to put here the clustered index, which allows us to physically give an order of rows. So in this way we can store the whole results as kind of physical table, let's say, pretty similar to that. And the second way to store our data via views is using materialized views. Mainly I was using the PostgreSQL, but they are also in Oracle. There are small differences about refreshing the data. But basically, materialized view is snapshot which exists in database in table-like form. So it was introduced in PostgreSQL 9.3. And basically about construction, the query and construction, the view. So you just basically need to add the materialized word, let's say, and it is created. Yeah. So what are the pros and cons of using the materialized views. But the first thing that you have to remember that, as I said, the data is stored in database. So the thing is, the performance is for sure better.
Okay, so I hope it is recording again. So okay, so there were like indexed views and materialized views, as I mentioned, and both of these types of views, they store the data in the database physically. So this is the main difference between those views and the normal common views, let's say. And the thing is, the indexed view is refreshed automatically in SQL Server, but with materialized views there is such thing that performance is obviously increased because the data is stored. But there is one thing that we have to care about. It's refresh materialized view. So exactly like this word is kind of simple. I think it's you have to refresh those views to keep data updated, just simply like that. And in general, pros and cons of materialized views is definitely performance, as the data is stored like in the table, so it's available immediately. The data update takes place in the external process, so user actually isn't really bothered about what happened in the background. The data is stored in one place, so it's as pros from simple view. The data also may be indexed, as in the normal table. You can put unique index, you can put multiple index on multiple columns. It doesn't matter. But the cons of that are that the data might be just outdated. So because of the refresh phrase of the must being refreshed, so the data, as I mentioned, might be outdated, and you need to automate the process of data updates by yourself. So you simply, when you update the table from which this view is dependent, you just need to also updating this table, you need to update the view. And again, the next cons and the last one here is that you always have to update whole view. There is no way to update single row on just part of this view. There is no way to do that. Always the whole view needs to be updated.
Oh. So the basic how to use those views. So I made a simple example. Let's say there is like table with names, and those let's say accounts are connected with transactions by the reference on name, and those transactions got some let's say amounts. Those amounts are from minus 100,000 to 100,000, let's say, and in every to this table I put like 30,000 records, and they are just they will be, let's say, joined to create a view from all of them. It's just an example for purposes of showing how the view works, instead of that we could just put those data into one table, but it doesn't matter here. So the definition here of common view is just we can create view and we just join the transactional accounts. And here we define the materialized view, also with our keyword materialized. And here I also needed to add some row numbers. I took them also from transactions, but I just created them here. It doesn't actually matter how it is created now, because it wasn't about performance of creation of view rather than gathering data. And let's say we would like to call some query on this view. So the normal view is like basically calling the query with additional condition where amount is below 0. So here we can see the whole join plan and execution. And as you can see, the execution time is like, okay, for now it doesn't look really long because it's at 24 milliseconds, but in comparison of materialized view, it's all, so the materialized view avoids whole planning time and execution time for joins and so forth. And it gives only the filter where amount is below 0 because it operates on the data, not on the results of query. So here it's like almost like near 4 times faster for just really simple data. So what I was talking about, it was about refreshing the query, refreshing the view, materialized view. And the thing is, there's one thing that was problematic for users because they cannot reach the data. During refreshing the data in this materialized view, they are not allowed, there is a log to read action and it's not possible. So in PostgreSQL 9.4 there was introduced something like concurrently refresh, and it means that user is able to see the results. They are still like old results, but he can reach them during the action of update of the view. But there are a few conditions. So the first is that we have to create a unique index. It was the reason that I've created the ID for materialized view, and this unique index cannot include any where class. The reason for that is because when PostgreSQL tries to update concurrently, it makes something like a temporary materialized view. It makes the full outer join with the old one, and it compares those two views and updates the old one. And then is the reason the unique index needs to be here. So simply because also as comparison, I used the refreshed materialized view, and I refreshed materialized view also concurrently. So as we can see, normal refresh is much faster, but for the price that user cannot read the data. And refresh concurrently is much longer because here it's almost 7 times, around that, yeah, 7 or 8. But the user still can read the data. So going further, I would like to introduce you the GAM that allow us to include the views into Ruby on Rails application easily. So it's called Static. The address is here that you can reach. And what is Static used for? Basically, it adds method to active record migrations and allows to create and manage the views here. So it supports when I was starting with that, like 1 year ago, it supported only the PostgreSQL. For now, there is support for MySQL, but only for views, because there are no materialized views for Oracle. For SQL Server, there are also no materialized views, and SQLite also no materialized views. So basically, the best is for PostgreSQL and Oracle, because both of these databases support the materialized views. So in general, we just call the Rails generator with the Scenic, and there is the basic structure which is created, so there's a migration. And there is our definition of SQL that we want to use to our view. Here there is a definition of migration, so here we can see that for materialized view we can add indexes, so there is a sample index, and schema definition is again our creation of view, and sample query that we would like to put. It's in the same way, the query is written in the same way that is done in our SQL view under migrations. And this is this kind of important thing for materialized views is refresh. So as we can see, we can include the option concurrently. And one more thing which is kind of important is it's cascade option, but I will tell about that in a while. Why to use the scenic gem? It brings everything we need about views to ROR application. It allows to create views materialized ways in Rails way. Depends on SQL engine what we can use. It gives ability of versioning views with drop, update, or replace view. We can also define the view as a model with ability of using active record, so we can go further with scopes and such things. Usually we should just lock it to being read-only, as still it is the view, so we cannot use any inserts or updates and so forth. And the last thing that I would like to mention is about this cascade option. So cascade option allows us there might be an issue that we've got the view, which brings the data from another views. So if we want to update this specific view, we also should update those views that brings the data to this updated view. So the cascade options just send, let's say, information to also update the views that are higher in hierarchy. So as I said, I would like to also talk about our real-life example. So let's say we had the grocery shop with workers hired via schedule or rosters, and this app was pretty similar to such app. I don't know if you heard about it. It's Instacart. So Instacart is basically shop that allows you mobile shop. Which allows you to order and the grocer is going to the shop. It brings the stuff. He buys the stuff and it brings it to your home. Yeah. So it's basically how Instacart is working. So here's the driver is going. He picks groceries and delivering to the customer. And the important thing here is how works the order system, because you need to be sure that you've got the slots, time frames, which allows you to order you an order basically. So order is available and spots to order something. This time slot is available for you, and. So as I said, we had a similar story with those problems, when grocers are available and when order can be realized. So the use case of this example is that customer should see available hours to which is dependent on. So when the shop is open, when the grocer is working at the shop, grocers working hours, and when there are available grocers to prepare order in specific delivery time frame. So in first iteration we just went the, let's say, Rails way, so most of the problems solved at the application layer side. Many small methods, many Ruby procedures, process calculations, and some tries of caching or something like that. But we kind of avoid more complicated queries, let's say, like most going by step and collecting data and processing it in Ruby. So the first iteration looked like that we had a request. The most important are data for which we want to collect the time slots that are available to make an order. And in the response, for example, for there's around 10 or 11 dates, we had about 200 objects. Yeah. So as the result of that was the response of this, the response of this request gave us almost 6 seconds, 5.5 second time, which is for, let's say, it was mobile application, so for API it's like pretty long, and client wouldn't be satisfied probably. So obviously we had to increase the speed of this endpoint. So issues here were, we were calculating one simply delivery time logic, and it was used in multiple places, like fees, checkouts, pre-orders, and so on and so forth. And mobile application API's response time should be quick in order not to block the web servers, but it became really painful in this respect, yeah? So we had to do something about that, and the thing was, so let's put more into SQL, and let's try to also make it as kind of abstract logic, so let's try to use some views. So we went there and we have written like a query which was operating like at once in the database side, so we can easily collect when the grocer is available. Also important thing here was, because when grocer was working, he could be, let's say, hired in schedule way or roster way. So schedule way was how he works on Monday, Tuesday, Wednesday, and so on and so forth, but also he could be hired with a roster, so it was planned for the date, specific date. So he had his weekly like work routine, but he could have changed the work routine for the specific date with date, and roster was always over the schedule, so we have to first get data from the roster, and then get if the roster wasn't here for the specific data which was in request, we were looking for schedule. And the migration was created like that, so it's simple, created by Scenic. So the actual response for this request was around 2 times faster. So moving completely with this logic to SQL with views like helped a lot here. But we thought that, okay, so grocers doesn't change their working hours like really often, the data is pretty stable. It's not a problem if it won't be updated all the time, or even if it will be, it can be updated in the night or something like that. As it depends when the owner will update the grocer's hours, let's say. So we thought that maybe we can go with materialized views if the data is not updated so often. And it was quite easy to do it in Scenic because we just went and added the materialized true, added some indexes on IDs, and added the unique index which allowed us to use refreshing concurrently, which gives us a result as again improvement about 1 second in comparison to normal view, and it was almost 4 times faster than using just a simple raceway. So it was pretty huge improvement, I think, and it was a good idea to use materialized view here. It gave us huge advantage, and it just passed, let's say, it's passed the exam. So at the end, as a summary, I would like to tell, like, because some people sometimes say, why do you not to use table view and materialized view, because it's materialized view is something between the table and view. But basically, as the table stores the data, returns the data, and can modify its data. And the view stores query, executes query, and returns results. And materialized views is something between here. So it's good to remember that it's neither this and nor the view, as it stores a query and stores a results. But in the same way, it cannot modify its data, and it returns stored results. So it's pretty similar to the table in here. Yeah. So basically, by my experience, it's a good idea to try. It's not always useful, but you have some historical data, or some statistics that doesn't need to be updated in a while or something like that, it's a great idea to use Materialized View and just give it a shot, let's say. So thank you, it's all. And do you have any questions?
Does the scenic grab the results into some kind of magic record objects, or is just the plain array with the hashes?
I think it's plain hash objects as I remember. So anything more?
No, to dzięki.
Thank you.